NEC Article 300.4 mandates that cables must be protected from physical damage. NEC Article 333 further clarifies that cables installed on interior surfaces of walls or ceilings must have at least 1 and 1/4 inches of protection from the finished surface. In your specific scenario, the cables are placed within cut grooves in brick walls, finished with a plaster skim coat. Because there will be no additional covering on the walls, the plaster skim coat is considered the finished surface. Consequently, the 1 and 1/4 inch depth requirement is applicable. Given the limitations of the brick wall's structural integrity, adhering to this requirement can pose a challenge. One potential compromise is to utilize BX cable with a reduced diameter, which would allow for shallow grooves. Alternatively, investigate the possibility of using a recessing device or trim plate that extends the cable from the wall surface, thereby meeting the depth requirement. It is important to ensure the plaster is applied smoothly and evenly around the cables to prevent any sharp edges or protrusions. Should the cables be exposed to moisture or excessive heat, additional protection measures may be necessary. This could involve using water-resistant BX cable or installing a heat shield. It's highly recommended to consult with the project engineer or architect. This collaboration facilitates discussions regarding alternative solutions that satisfy NEC requirements while preserving the intended aesthetic design. While the inspector's interpretation of the NEC is indeed accurate, exploring alternative solutions may be necessary to meet both the safety and design requirements of the project. By maintaining close collaboration with the architect and engineer, a solution can be found to comply with the code, while preserving the desired historic look of the condo units. When installing electrical cables, especially BX cable, within walls, a thorough understanding of the National Electrical Code, or NEC, is essential. The NEC provides guidelines to ensure electrical safety and prevent potential hazards. Article 300.4 addresses the protection of cables and raceways from physical damage. This article emphasizes the need to safeguard electrical conductors from potential harm, such as punctures, abrasions, or impact. The primary goal is to prevent insulation damage that could lead to short circuits, current faults, or even electrical fires. Article 333 specifically covers armored cable, or BX cable, which is a common wiring method used in residential and commercial buildings. This type of cable consists of insulated conductors encased in a flexible metal sheath, providing a degree of physical protection. However, even with the metal armor, BX cable is still susceptible to damage if not installed correctly. Article 333 outlines the requirements for installing BX cable in various locations, including walls, ceilings, and floors. The specific requirement of 1 and 1/4 inches of clearance from the finished surface, mentioned by the inspector, is crucial. This clearance is intended to protect the cable from being easily damaged by nails, screws, or other objects that may penetrate the wall. The finished surface refers to the final layer of the wall, such as drywall, plaster, or paneling. If the cable is installed too close to the surface, it becomes vulnerable to accidental penetration, which can compromise the insulation and create a safety hazard. In situations where achieving the 1 and 1/4 inch clearance is challenging due to structural limitations, several alternative solutions can be considered. Firstly, using BX cable with a smaller diameter may be an option. A smaller cable will require a shallower groove, making it easier to meet the depth requirement without compromising the wall's structural integrity. Secondly, employing a recessing device or trim plate can effectively extend the cable away from the wall surface. These devices create a protective barrier around the cable, ensuring it is adequately recessed from the finished surface. A recessing device is typically a plastic or metal box that is installed within the wall cavity. The BX cable is then routed through the box, providing a physical barrier between the cable and the wall surface. Trim plates, on the other hand, are decorative covers that are installed over the cable after it has been secured to the wall. These plates not only provide protection but also conceal the cable for a cleaner appearance. It is important to select a recessing device or trim plate that is specifically designed for use with BX cable and is listed by a recognized testing laboratory, such as Underwriters Laboratories or UL. This ensures that the device meets the required safety standards and is suitable for the intended application. When applying plaster around the cables, it is crucial to ensure a smooth and even finish. Any sharp edges or protrusions can create stress points on the cable, potentially damaging the insulation over time. The plaster should be applied in multiple thin layers, allowing each layer to dry completely before applying the next. This will help to prevent cracking and ensure a durable finish. If the cables are exposed to moisture or excessive heat, additional protection measures may be necessary. Water-resistant BX cable is specifically designed for use in damp or wet locations. This type of cable has a moisture-resistant jacket that protects the conductors from corrosion and water damage. Heat shields can be used to protect the cables from excessive heat. These shields are typically made of metal and are installed between the cable and the heat source. It is essential to choose a heat shield that is rated for the expected temperature range. Consulting with the project engineer or architect is highly recommended, especially when dealing with complex installations or when faced with challenging structural limitations. These professionals can provide valuable insights and guidance on selecting the appropriate wiring methods and protection measures. They can also help to ensure that the installation complies with all applicable codes and standards. The NEC is a comprehensive document that covers a wide range of electrical installation. It is important to stay up to date with the latest edition of the NEC and to consult with qualified professionals when necessary. By following the NEC guidelines and implementing appropriate protection measures, you can ensure the safety and reliability of electrical systems. In the specific scenario described, where the architect has chosen to preserve the original look of the brick walls by avoiding drywall, it is crucial to find alternative solutions that meet both the aesthetic and safety requirements. One approach is to carefully plan the cable routing to minimize the depth of the grooves required. This may involve running the cables along existing mortar joints or utilizing other concealed pathways. Another option is to explore the possibility of using surface-mounted raceways. These raceways are typically made of metal or plastic and are designed to enclose and protect electrical cables. Surface-mounted raceways can be painted or finished to match the surrounding wall, minimizing their visual impact. When selecting surface-mounted raceways, it is important to choose a product that is specifically listed for use with BX cable and that meets the required fire resistance rating. In conclusion, installing BX cable in brick walls with a plaster skin coat finish requires careful consideration of the NEC guidelines and the structural limitations of the wall. By exploring alternative solutions, such as using smaller diameter cable, recessing devices, trim plates, and surface-mounted raceways, it is possible to meet both the safety and aesthetic requirements of the project. Collaboration with the project engineer and architect is essential to ensure that the installation complies with all applicable codes and standards. Remember, electrical safety should always be the top priority. A properly installed electrical wiring can create a significant risk of fire, electric shock, and other hazards. By following the NEC guidelines and seeking professional guidance, you can ensure the safety and reliability of electrical systems for years to come. In addition to the points already discussed, it's vital to consider the following aspects when working with BX cable installations. First and foremost, always ensure that the power supply to the circuit is completely turned off before commencing any electrical work. This is a fundamental safety precaution that prevents accidental electric shock. Secondly, when cutting BX cable, use a specialized cable cutter designed for this purpose. These cutters provide a clean and precise cut without damaging the insulation of the conductors inside. Thirdly, after cutting the cable, it's essential to remove any sharp edges or burrs from the cut end of the metal sheath. These sharp edges can damage the insulation of the conductors as they are pulled through the cable. Fourthly, use anti-short bushings or redheads at the cut ends of the BX cable where it enters a metal box for fitting. These bushings protect the conductors from abrasion and prevent short circuits. Fifthly, when securing BX cable to walls or ceilings, use cable staples or straps specifically designed for this purpose. These fasteners should be spaced appropriately to provide adequate support for the cable and prevent it from sagging. Sixthly, avoid bending BX cable excessively, as this can damage the metal sheath and the insulation of the conductors inside. The NEC specifies the minimum bending radius for BX cable, which should be adhered to. Seventhly, when connecting BX cable to electrical boxes or equipment, use connectors specifically designed for BX cable. These connectors provide a secure and reliable connection while also protecting the conductors from damage. Eighthly, always ground the metal sheath of the BX cable to provide a path for fault current in case of a short circuit. This grounding is typically achieved by connecting the cable's grounding conductor to the metal box or equipment. Ninthly, inspect the completed installation thoroughly to ensure that all connections are secure, that the cable is properly supported, and that all safety requirements are met. Tenthly, after completing the installation, test the circuit to verify that it is functioning correctly and that there are no ground faults or short circuits. And beyond these 10 aspects to consider, always consult the latest edition of the NEC and any applicable local codes for specific requirements and guidelines related to BX cable installations. Remember that electrical work can be dangerous if not performed correctly. If you are not comfortable or experienced with electrical work, it is best to hire a qualified electrician to do the job. Now let's delve deeper into some of the technical aspects of BX cable and its installation. BX cable, also known as armored cable, consists of insulated conductors wrapped in a flexible metal sheath. This metal sheath provides a degree of physical protection for the conductors, making BX cables suitable for use in locations where it may be exposed to mechanical damage. The conductors inside BX cable are typically made of copper and are insulated with thermoplastic or thermosetting materials. The size and number of conductors in the cable will vary depending on the intended application. BX cable is available in a variety of sizes and configurations, ranging from small cables used for lighting circuits to larger cables used for powering appliances and equipment. The metal sheath of BX cable is typically made of steel or aluminum. Steel is stronger and more durable than aluminum, but it is also heavier and more susceptible to corrosion. Aluminum is lighter and more corrosion resistant, but it is not as strong as steel. The choice of metal sheath will depend on the specific application and the environmental conditions. When installing BX cable, it is important to select the appropriate size and type of cable for the intended application. The NEC provides guidelines for determining the appropriate cable size based on the ampacity of the circuit and the ambient temperature. The ampacity of a cable is the maximum amount of current that it can safely carry without overheating. The ambient temperature is the temperature of the surrounding environment. It's vital to consider voltage drop when selecting the cable size. Voltage drop is the decrease in voltage that occurs along the length of a cable due to its resistance. Excessive voltage drop can cause equipment to malfunction and can even damage electrical components. The NEC provides guidelines for calculating voltage drop and for selecting cable sizes that will minimize voltage drop. When running BX cable through walls or ceilings, it is important to protect it from physical damage. This can be achieved by using conduit, sleeves, or other protective measures. Conduit is a rigid metal or plastic tube that is used to enclose and protect electrical cables. Sleeves are short sections of conduit that are used to protect cables where they pass through walls or ceilings. Other protective measures include using nail plates to protect cables from being punctured by nails or screws. When installing BX cable in damp or wet locations, it is important to use water-resistant cable and fittings. Water-resistant BX cable has a moisture-resistant jacket that protects the conductors from corrosion and water damage. Water-resistant fittings are designed to prevent water from entering the cable and damaging the conductors. When terminating BX cable at electrical boxes or equipment, it is important to use connectors specifically designed for BX cable. These connectors provide a secure and reliable connection while also protecting the conductors from damage. The connectors should be properly tightened to ensure a good electrical connection. When grounding BX cable, it is important to follow the NEC guidelines. The metal sheath of the cable should be grounded to provide a path for fault current in case of a short circuit. This grounding is typically achieved by connecting the cable's grounding conductor to the metal box or equipment. The grounding conductor should be properly sized according to the NEC guidelines. After completing the installation, it is important to inspect the work thoroughly to ensure that all connections are secure, that the cable is properly supported, and that all safety requirements are met. The inspection should include checking for any signs of damage to the cable or fittings. The inspection should also include testing the circuit to verify that it is functioning correctly and that there are no ground faults or short circuits. Regular inspections and maintenance are essential to ensure the continued safety and reliability of electrical systems. Any problems or defects should be corrected promptly to prevent potential hazards. By following the NEC guidelines and implementing appropriate installation and maintenance practices, you can ensure the safe and reliable operation of BX cable electrical systems.